Welcome to the chapter on Fundamentals of OSI Networks, Protocols, and Models. This chapter is your essential starting point before diving into any cybersecurity or DevSecOps practice. Whether you are aiming to conduct penetration tests, identify vulnerabilities, or build a secure delivery pipeline, you must first understand how data actually travels across networks, how machines communicate, and what rules govern these exchanges. Without this foundation, tools like Nmap, Wireshark, or Metasploit remain black boxes. With it, they become powerful instruments you can use with precision and intent. This welcome section introduces the goals of the chapter, explains why this knowledge is indispensable for a cybersecurity specialist, and gives you a clear map of what you will learn and how it connects to your professional objectives. Why network fundamentals matter in cybersecurity. Every attack and every defense happens on a network. When an attacker exploits a vulnerability in a web application, data packets are sent and received. When a security tool scans a system for open ports, it sends specially crafted network messages. When you analyze traffic with Wireshark, you are reading raw network data. If you do not understand how networks are structured, how protocols work, and what a normal versus abnormal exchange looks like, you cannot perform meaningful security work. Consider a simple example. Imagine you are conducting a penetration test on a web application. You notice that an HTTP request to a certain endpoint returns sensitive user data without requiring authentication. To understand why this is a vulnerability and to document it correctly in a report, you need to know what HTTP is, how requests and responses are structured, what authentication headers look like, and at which layer of the network this exchange occurs. Without this context, you cannot explain the risk, reproduce the attack reliably, or recommend a proper fix. Another example. You are setting up a secure delivery pipeline that includes dynamic application security testing. The testing tool sends HTTP and HTTPS requests to your application and analyzes responses. If you do not know the difference between HTTP and HTTPS, what transport layer security means, or how ports are assigned to services, you cannot configure this tool correctly or interpret its results. The Open Systems Interconnection Model. An overview. The Open Systems Interconnection Model, commonly called the OSI model, is a conceptual framework created by the International Organization for Standardization. It was designed to standardize how different computer systems communicate with each other, regardless of their underlying hardware or software. The model divides network communication into 7 distinct layers, each with a specific role and set of responsibilities. These 7 layers, from bottom to top, are: Layer 1, Physical Layer. This is the lowest layer. It deals with the actual physical transmission of raw binary data, zeros and ones, over a medium such as a copper cable, fiber optic cable, or radio waves. It defines electrical voltages, light pulses, connector types, and transmission speeds. An example of a device operating at this layer is a network cable or a repeater. Layer 2, Data Link Layer. This layer is responsible for node-to-node data transfer and error detection within a single network segment. It packages raw bits into frames and handles addressing using hardware addresses, known as media access control addresses. Switches and network interface cards operate at this layer. The Ethernet protocol is a prominent example of a data link layer protocol. Layer 3, Network Layer. This layer manages the logical addressing and routing of data packets between different networks. It determines the best path for data to travel from source to destination across multiple networks. The Internet Protocol, both version 4 and version 6, operates at this layer. Routers are the key devices here. An IP address like 192.168.1.1 is a Layer 3 concept. Layer 4, Transport Layer. This layer ensures reliable or fast end-to-end communication between two hosts. It handles segmentation, flow control, and error correction. The two main protocols here are the Transmission Control Protocol, which provides reliable, ordered, and error-check delivery, and the User Datagram Protocol, which provides faster but less reliable delivery. Port numbers, such as port 80 for web traffic or port 443 for secure web traffic, are a transport layer concept. Layer 5, Session Layer. This layer manages and controls the connections, sessions, between two communicating systems. It establishes, maintains, and terminates sessions. An example is a session established during a remote desktop connection. Layer 6, Presentation Layer. This layer is responsible for data translation, encryption, and compression. It ensures that data sent by one system can be read by another, even if they use different formats. The encryption performed by Transport Layer Security operates conceptually at this layer. Layer 7, Application Layer. This is the topmost layer, closest to the end user. It provides network services directly to applications. Protocols such as Hypertext Transfer Protocol, File Transfer Protocol, Domain Name System, and Simple Mail Transfer Protocol all operate at this layer. When you type a website address into a browser, the browser uses application layer protocols to fetch the page. Why the OSI model is critical for security professionals. The OSI model is not just a theoretical diagram. It is a practical diagnostic and analytical tool. When you perform a network scan with Nmap, you are working primarily at layers 3 and 4, probing IP addresses and port numbers. When you capture and analyze packets with Wireshark, you can see data at all layers simultaneously, from the physical frame headers to the application-level HTTP content. When you exploit a vulnerability using Metasploit, the exploit travels through multiple layers before reaching its target. Understanding the model also helps you identify at which layer a vulnerability exists, which directly informs the corrective action. For example, a misconfigured firewall that allows all traffic on port 22, secure shell, is a layer 4 issue. An unencrypted HTTP connection that exposes login credentials is a layer 6 or layer 7 issue. An address resolution protocol spoofing attack, where an attacker sends fake hardware address mappings to redirect traffic, is a layer 2 attack. An IP address spoofing attack is a layer 3 attack. Knowing the layer helps you choose the right tool, apply the right defense, and write a more accurate vulnerability report. Protocols and their role in network communication. A protocol is a set of rules that define how data is formatted, transmitted, received, and acknowledged between communicating systems. Protocols exist at every layer of the OSI model. Without protocols, different systems and applications could not communicate. Some of the most important protocols you will encounter throughout this course include Hypertext Transfer Protocol, HTTP, used by web browsers and servers to exchange web pages and data. It operates at layer 7 and transmits data in plain text, making it vulnerable to interception. Hypertext Transfer Protocol Secure, HTTPS, the encrypted version of HTTP, which uses transport layer security to protect data in transit. It also operates at layer 7 but provides confidentiality and integrity. Domain Name System, DNS, translates human-readable domain names like www.example.com into IP addresses. It operates at layer 7 and uses both User Datagram Protocol and Transmission Control Protocol on port 53. Transmission Control Protocol, TCP, provides reliable, connection-oriented communication. Before data is sent, a three-way handshake is performed. The client sends a SYN message, the server responds with a SYN ACK, and the client replies with an acknowledgement. This process establishes a session. User Datagram Protocol, UDP, provides fast, connectionless communication without guarantees of delivery. It is used for applications like video streaming or DNS queries where speed matters more than reliability. Internet Protocol version 4, IPv4, the most widely used network layer protocol. It uses 32-bit addresses, allowing for approximately 4.3 billion unique addresses. An example address is 10.0.0.1. Internet Protocol version 6, IPv6, the newer version designed to address the exhaustion of IPv4 addresses. It uses 128-bit addresses, providing a vastly larger address space. An example address is 2.0.0.1.0.db.8. 8.5.a.3. 0.0.0.0.0.0.0. 8.a.2.e.0.0.0.0.3.7.0. 7.3.3.4. Address Resolution Protocol, ARP, used to map an IP address to a hardware, media access control, address on a local network. It operates between layers 2 and 3. Chapter Goals and Learning Outcomes. By the end of this chapter, you will be able to describe the purpose and structure of the Open Systems Interconnection Model and identify the function of each of its 7 layers. Explain how data is encapsulated as it moves down the OSI layers and de-encapsulated as it moves up on the receiving end. Identify the key protocols used at each layer and describe their role in network communication. Understand the difference between connection-oriented, transmission control protocol, and connectionless, user datagram protocol, communication, and recognize when each is used. Recognize how IP addressing and port numbers work together to direct traffic to the correct application on the correct machine. Understand why unencrypted protocols such as HTTP represent a security risk and how encryption protocols such as transport layer security mitigate this risk. Apply this knowledge as a foundation for using security tools like Nmap, which scans network hosts and open ports, Wireshark, which captures and displays network packets, and Metasploit, which delivers exploit payloads across networks. Use the OSI model as a diagnostic framework to identify at which layer a vulnerability or attack is occurring, enabling more precise reporting and remediation. Connecting theory to professional practice. This chapter sets the stage for everything that follows in the course. When you study web and application penetration testing, you will trace attack vectors across HTTP, HTTPS, and DNS. When you study authentication and session vulnerabilities, you will understand how session tokens are transmitted at the application layer. When you learn about injection attacks, you will see how malicious payloads travel through the network stack to reach a database. When you set up a continuous integration and continuous delivery pipeline with security testing tools, you will configure scanners that interact with your application over the network using the same protocols you study here. The OSI model and network protocols are not abstract academic concepts. They are the language of every security tool, every attack technique, and every defense mechanism you will encounter as a cybersecurity and DevSecOps specialist. Mastering this foundation is not optional. It is the prerequisite for everything else. Take the time to understand each layer, each protocol, and each example provided in this chapter. Read actively, take notes, and think about how each concept connects to the security scenarios described above. The multiple-choice assessment that follows this text will test your understanding of these concepts in precise and practical ways. Be ready to identify layers by their number and name, match protocols to their correct layers, and explain the security implications of how data is transmitted across a network.